We have a curve C where y is inversely proportional to x. So that means y is proportional to 1 over x. And y equals k over x. As one doubles, the other doubles, so they're just separated by a constant, essentially. And we want to work out what this is, and we've got a point, so we can do that. So minus a half is equal to k over 1, and therefore k is equal to minus a half. And we can write, you could write it as y equals minus a half over x. It actually makes more sense to, you can separate this to k times 1 over x. So we can write y equals minus a half times 1 over x. And because we're asked for the gradient function, I'm going to put it in power form. So minus a half x to the minus 1. Note, you could also write it as y equals, you could bring the fractions together and write it as minus 1 over 2x. That's an alternative as well. So being able to go between all these different representations is important. So for the gradient function, we multiply by the power, so actually the minuses are going to cancel, and then we reduce the power by 1. So there we go, which we could then write as 1 over 2x squared, or a half times 1 over x squared, if you prefer. Okay, I think you'd be okay with this one as well, but this is a bit neater, and it's going to be easier to do the sketch, which is the next bit. So for the sketch, kind of forget about the 1 over 2 part, just focus on 1 over x squared. 1 over x squared actually looks a lot like 1 over x. This is 1 over x, but instead of it being ever negative, we're always squaring, so it's positive. So in fact, it's like this. Okay, I probably should try and make it a bit more symmetrical. Okay, pretty happy with that. So as x gets big, it approaches 0. When x gets small, it just gets bigger and bigger. And tends to infinity. This is called an asymptote. Actually, there's two asymptotes. The x-axis and the y-axis are both asymptotes. The diagram indicates that the curve C has no stationary points. State what feature of our sketch in part 2 corresponds to this. Well, to get a stationary point, you have to have dy by dx equals 0. So I think it's worth, and this is only 1 mark, but it's worth writing that down. But the graph in A part 2 never reaches 0. Just checking what I wrote. Yeah, dy by dx is never 0. Maybe I'll say dy by dx is always greater than 0, greater than 0. So there are no stationary points. Okay, I think I've probably written more than I need to, but better to be comprehensive than not enough. Finally, we're told that C is translated by the vector minus 2, 0. That's 2 units in the negative x direction, or 2 units to the left, informally speaking. Find the equation of the curve. So if you do x plus a like that, then it would translate the curve f of x a units to the left. So actually, what we're going to get here is f of x plus 2 in function talk. In terms of our function, we're going to remember we've got y equals minus 1 over 2x. So all I need to do is replace that x by x plus 2. I'm not going to go into any more detail on transformations here. It's like, it's a case of practicing and learning them and understanding them, which I've got a video on that, so have a look at it if you're not happy. But otherwise, that's the way you deal with the translation. And so yeah, here's our answer. Okay, well done.